Good morning, good afternoon, good evening, whatever the case may be, and welcome to example 2 for chapter 12, day 1, linear regression and inference. Okay, so in our second example, and you can find this in the textbook, just kind of put the things together. I want you to check this out. All right, we would say that cars and trucks lose value the more they are driven. All right. A random sample of 16 trucks was selected among those listed on auto sales website. The number of miles driven and price in dollars were recorded for each of the trucks. Here are the data, right? So we have this data, all that stuff set up. Computer output from a least squares regression analysis is also shown. Okay, so we come over here and we check this out and say, okay, well, what are we going to do? What do we need to set up here? All right, so here we are asked to simply use the 4-step process and the liner acronym to construct and interpret a 90% confidence interval for the slope of the population regression line. Okay, so liner acronym is for our condition. So we'll start with that. Okay. L. Do we have a linear relationship in the scatter plot? Yes, right. Maybe it's moderate, maybe it's strong, but we definitely have a linear relationship in the scatter plot. I, independence. Well, this is not an experiment. It's just a sample survey, so we need to meet the 10% condition. And that's meant sample size of 16 is less than 10% of the population, which would be all of the listed trucks on the auto site, right? So this is where the I comes in. Okay, then N, we need to have normality, right? Well, if we look at the residual of our, the histogram of our residuals, it's approximately normal. Okay. We could also over here and see that there's no clear pattern in the residual plot. Without a clear pattern, this is what the histogram is going to look like. We could also check out the normal probability plot or the QQ plot, but really look at the histogram of the residuals, right? Or look to see that there's no clear pattern here. E for equal variability, right? Well, the variability of the residuals is about the same regardless of the miles driven or the X values, right? All of these are about the same in terms of how far away at the different miles driven you are from that zero line, right? They're, about similar distances away in general. Right, and then the R for random selection. Well, we did have a random selection of the 16 trucks, right? It's up here, right? This is our R, right? So we have LIN, right? And we can look over here to our E and R. Okay, so our 4-step process. What's our 4-step process? Well, we need a state. We are looking to estimate the slope beta of the population regression line relating miles driven to price. So what we're saying is miles driven is going to affect our price, right? But really and truly, we should say relating price to miles driven, right? And the reason being is that really we say you relate Y to X, right? And so the first thing is what you are predicting, your dependent variable, and the second is your independent variable, all right? So really we should say price to miles driven rather than miles driven to price, right? Because price is changing based on miles driven, but that's what we're trying to find, right? We're trying to estimate this slope. We're going to use a confidence interval, right? 90% confidence. Okay. Our plan, are the conditions for inference met? Yes, they are. We went through that whole liner process, and so we can now do a t-interval for beta, the slope, right? Very important, that notation. Very, very important. Did you catch it? Very important. Okay, now our do. The degrees of freedom is 16 minus 2, which is 14, right? And the critical value at 90% is 1.761. Or can we get that? Here we are. Here's our table. Let's check this out. Okay, so 90% confidence, we come up to 14, right? There's 14, boom, 1.761. That's where that value comes from. Okay, so here we have then 1.761. We're going to have B plus or minus T star, right? Standard error, right? So we come over here, and how do we get those? Well, we see that our slope is right over here. That's our estimate, the negative 1.6292. All right, and we see right over here the standard error for that slope. And so that's what we have down here, negative 1.6292 plus or minus 1.761, and then 0.03096. And that interval is going to be negative 0.217 to negative 0.108. Okay. How can we do that with our calculator? Well, pretty straightforward. We can come over here. Let me second plus 712, clear this out. Okay, so I can go stat and I can do a test and I have a t interval that I'm trying to set up. I'm just going to do it with stats, right? And x bar, what's the statistic that we found? Well, the statistic that we found was right there, the negative 0.16292, right? 16292. Okay, the standard error of our statistic, well, that was the 0.03096, right? Sample size was 16. Confidence level 0.90. Calculate this, boom, and we look at this and we say, well, hey, wait a second, why did we not get our same value, right? Well, let's just double check to see what would be occurring here. Okay, we have negative, right, negative 0.16292, right? Is that the right number? Yes. All right, and then plus 1.761 times, let's see here, times 0.03096. All right, there's that negative 0.108. That's fine, right? And then over here, minus. That's fine. So I'm not quite certain what I pushed wrong on the buttons, but that's why I prefer to write this out in this way. I'll double check that, maybe post a video for how it should actually be set up. But now our interpret, because the last piece is to interpret as well, and we are 90% confident that the true slope of the regression line relating price to miles driven, relating y to x, okay, remember it's y to x, is within negative 0.217 to negative 0.108, right? And this really would be in terms of dollars or thousands of dollars or whatever our units happen to be, okay? So hopefully everything makes a little bit more sense. You have one more example that you need to do. I'm not going to put a video up for that. And then you also will have a couple of problems possibly that we're going to ask you to try and complete, okay? So otherwise, make sure you Zoom, make sure that you email, make sure you do your work, and good luck to you.